And then let me share my screen. Share. Okay, here we go. Welcome back to the machine learning class. So first of all, in the last time we mentioned the basic concepts of machine learning, plus a part of the Python tutorial 1, which is lecture 2. I believe we finished here. Lecture 17. Oh, before doing these, let me mention one more thing, which is so I created this in the share drive. I created this Google Sheet in which you can see for example the class date and then corresponding video and basic description of the content. So you just click it, then you can see the video where. Here we go. So you click it, then you will see it. So, just in case you didn't take part in the class, so you can go to the class. Okay, now let's go back. By the way, also another thing is lecture slides are all here. So these are all the things. Uh, Based on my teaching experience before, I'm not gonna directly put, this kind of directly the code. I mean, copyable code there because I want you guys, especially who are not familiar with Python, to write it by yourself instead of just copy and paste. Okay, let's start our main thing here. So last time we mentioned the f print. So basically we can put the f parameter in print to let Python know that it's here. And whenever I need a variable, I can just put my variables here in the bracket so that Python will know. Let's do an exercise here. Ask the user to input a Fahrenheit degree and convert it to Celsius. So the conversion formula is Celsius equal to, excuse me, Celsius equal to Fahrenheit minus 32 parentheses over 1.8. Let's do it. So I remember, yeah, I created in class folder, and remember our main is stored under this panel, and then here click main, so we can just open the Python. Okay, here we go. Okay, here we go. So what's the name of this one? Exercise 2, 2. So let me have this one. So here, let me create another one called create new Python file exercise 2, 2. Okay, so I need to have user to input a Fahrenheit, right? So I can say, let's say f equals input how to spell, sorry. Can I copy and paste? Okay, great. I feel like pressure to spell this one, the Fahrenheit. Input a Fahrenheit degree. And then C equal to, let's say, F minus 32 divided by 1.8, 809. And then print F Fahrenheit degrees equals to C Celsius. Celsius degree. Okay. Guess what's gonna happen if I run this one? You know what? It will show you an error. Believe it. Let's try it. Let's say I put from 32 error. You know why? The reason because if here I have f is input, and this is gonna be a string, and string minus 32 are going to work. So to make my life easy, I can make it in this way, make it a float. Remember what we mentioned? So in this case, Python knows, okay, so this f is actually a float number, so that's a numerical versus numerical. We can do the operations. So let's do it again. Fahrenheit 32 should be 0. Hence, you see, 32 Fahrenheit degrees equals to 0 Celsius, or you can do whatever number. Let's say sorry. Let's say for example, let's say 98.6, which will be 37. Yeah, almost almost 37, which is our body temperature. Got a point. So that's how we. Oh, in my code here, I put a float here, but actually you put here is easier because otherwise you need to write a float for twice. I mean, you put it here just one time. So this is a very, very simple application for the input and the F print. Any questions here? No. Okay, then let's go. Okay, finally, we mentioned the list. I believe I actually, I mentioned the list several times, in the last lecture, but here we're gonna formally mention it. It's just a collection of string or number as a variable, which is ordered and changeable. But contrast, we actually have another three, structures, tuple, set, and dictionary. In this class, we're mainly gonna use list. I believe later we will use dictionary and set also. I forgot details, but mostly we're using list, and later we're gonna use in NumPy, we're gonna use the array. But well, let's have a look at it. What is a list? So here I have the courses. Let's say calculus, linear algebra, machine learning, and have the grade, and I can have the grade as string. All these are lists. I guess I'd better do it this way. Yeah, so that you can see a live code here. Okay, let me go back to my main. So my main is my main function to show those kind of class examples. Course equals to calc. Let me make it the same thing. Calc, then yeah, algebra, and also machine learning. I'd better make it consistent. And then I have what else? Grade 1 equals to wait, which is 80. Last one is 100. And grade 2 basically the same thing, but okay. 80, 100. Okay, then first of all I can print. I use a function called type. So type is gonna directly tell you what type it is. Let's say I print type course, type grade 1, and then type grade 2. Okay, so let me print it. You can see class list, class list, class list. Regarding what is the class, I will mention it either in the end of this class or in the next class. But basically what you need to see is list. So it tells me that, okay, all these three objects are actually lists. Okay, now let's do something interesting. Remember in the string, let me go back here. In string index, we can use, where it is? We can use index. Where's the index? Here we go. Indices of a string variable. We can use all those, remember? And always remember it starts from 0th element instead of the, first or to n. It's actually from 0 to n minus 1, where n is the length of the string, right? Okay. So here, list is a generalization. I should not say generalize. It's actually, a more general object, or let's say class, that it can include numbers or include strings, so that it's gonna have the same thing. Let's say here I'm gonna print course 0 to 1. What a name. So the 0th element is a string called calc. The first element is linear algebra. The second is machine learning, and you're gonna see exactly the same here. Here we go. Calc. Sorry, my fault again. I hate it. So again, A to B, A to B minus from A to B minus 1. My fault. Sorry. And hence here from calc, B minus 1 is 1. So it's linear algebra. It doesn't include the machine learning. If you want to include the machine learning, you can either write it this way. This means all the elements, or let's say 0 to 3. So here we go. So this is the thing. And similarly, I can do course -1, which is the last element or the last course, which is machine learning. Or I can do it like this way. Let's say grade 1 plus grade, my fault, grade 1 plus grade 1 2. So what that means? This means 80 plus 100 and the number should be 180. You may be confused that why do I need to have grade 1 and grade 2? And here's the reason. So suppose I use grade 2. So by human eyes, we may say, oh, 90 plus 81, 70, right? Wrong. The reason the reason is because, let's see it. You see what happens. 80, 100, 80, 1000. Why? Because these elements are strings. Because they're strings, remember, string plus means what? Concat. Basically, you're gonna have 80 and then append 100 after it. So it's going to be 80100. That's the reason. Be very careful of the type of the variables here. So this is some, simple things of the list. And let's see more examples. So here we say we've seen how to get the numbers, and then let's see how to change the numbers. Here I have a name equal to, what are the names? Mary, John. Let's say my name. Let me replace my name by Harry Potter. Harry. And then grade equals to say 90, 180. Okay, so how to change the name? Let's say the last name 0, 1, 2, the last name from Harry to Peter. So I can say name 2, or you can say name next to 1. It doesn't matter. The reason I use 2 just to let you know this is 0, 1, 2 equal to, let's say, Peter. Be careful, you must have this quotation. It doesn't matter double or single, but if you write in this way, Python will consider Peter as what? Will consider Peter as, sorry, no. Suppose I have not learned what is kind of a common. So Python will consider this Peter not as a string Peter, but as a variable Peter. It will ask you, hey, where's the variable Peter? It's not defined, and show you the error. Let's run it, and you will see. Name Peter is not defined. Did you mean it? No, it turns out another thing. So you must have the quotation here to let Python know that this is indeed a variable. Sorry, a string named Peter. And now let's print name again. Excuse me. And you can see the last name has been changed from Harry to Peter. So this is thing number 1. Or we can definitely do this way. Grade which one did I choose here? Also 2. From 80 to, let's say, 88. Then you can print grade as well, and you will see the numbers changed. It's 88 before related. So this is how can we change the variables. One thing I would specifically mention, which is extremely important in Python, is for a list, if I write it this way. Another thing equal to it, this means a mapping instead of create a new one. So let's say this. I have name, still these 3 names, right? I write it as name 2 equals to, let's say, name. So in many other languages, especially, I should say this, sorry, I should say if this is a variable, this means what? This means, okay, I have something else equal to this, right? Be careful, something also wrong. We still need to use the thing which is copy. But here I want to show you that if for this I write this way, it will be a disaster. So first of all, let's print name 2. Name 2 as name 2. So no surprise, it's just here, the same thing. Okay, the interesting things, what if I change an element in name? Let's say I replace the first name from Mary to Peter again. Now print name 1, name 2. Here I can just copy and paste. Name 2, let's say again. You'll be surprised here. At least I was surprised when I just started learning Python. So this is name, sorry. This is name 2 here. Let me add something here. So here, just add a blank. You can use /n. So here's the name 2. I have the name 2, which is before I make the change. So of course, name 2 should be equal to name, right? Okay. Now I make the name, change the first name to be Peter, and you can see I name 1, which is, the original name, did change, the first element to Peter. But you see what happens is name 2 also changed to Peter. You see what I mean? In other words, whatever the thing you do on name, it will be reflected on name too as well. Why? Again, this is simply, this is, no, sorry, not here. By the way, this is called comment, so I can write whatever comment here. Not here again. Name two is a mapping of name instead of a copy. So this is an extremely important thing. Never think that, okay, I changed name one, so name two will still be the same. No, name two will be different. But what if I really want, excuse me, what if I really want to use a copy instead of, kind of like whenever my name change, name two is also changed. Okay, I can use the copy method, which is let me see here. Oh, give me 1 second. It's not being introduced here. It will be later. Anyway, it will be introduced later, but basically you will use name.copy. So in this case, you will make it which is really a copy that with the change of name two will not be changed. Okay, the next thing I want to introduce is something like a matrix. So for those of you who are familiar with Python, you might know that we have a library called NumPy. And of course, in most cases, matrix, those kind of things, we're going to use the NumPy array. But what's the point for me still to introduce like the matrix as a list here? The reason, because if in some cases I have a very big one and I want to due to whatever the reason, I want to save the space, make it simple, I can simply use a list instead of really use the array, because array is going to make it a very big and also slow. So we can use excuse me, we can use matrix here. Matrix equals to here, let me use here is 1, 2, 3, 4, 5, 6. Oops, sorry. 7, 8, 9. Okay, so in this case, first of all, let me print it. Matrix. Okay, without any surprise, it's like this way. If you have known, if you have used MATLAB, you can see that MATLAB can also use this way. And also MATLAB, to be honest, is way better because MATLAB, you're gonna have something like this way. It's a 1, 2, 3, 4, 5, 6, 7, 8, 9. It's gonna be like this way. I personally prefer MATLAB. Unfortunately, in terms of business, MATLAB is a big failure. Anyway, I can talk several hours about this, but anyway. So here in Python, matrix like this way. So this is the first element of the outer layer matrix, second element, the third element. And then this one is the first, sorry, excuse me, let me use the term zeroth element because again, for Python, it starts from 0. And for this number 1 is the 0th element of the inner, list, inner list. In other words, this is a list in list. You see what I mean? So I can actually do like this way. Instead of printing the whole matrix, I can print something like this. For example, print matrix 0. Guess what's gonna happen? Matrix 0 is here. That tells me, okay, first we start from the most out layer, which is, this one, you know what I mean? So this is out layer. So its 0th element is 1, 2, 3. You see, 1, 2, 3. Although itself is a list, but yes, it is the 0th element of the out layer list or matrix, whatever you call. And of course, I can, one would be the middle one, which is 4, 5, 6, right? Okay. So, but what if I want to find this 5? Okay. So in this first element, you're going to put another 1. So 0th element, first element. So this will give you the 5 here. 5. Let me ask you how to get the 7. It's going to be what? First of all, 0, 1, 2. So this one will be 2, right? Because 2 shows this matrix, inner matrix list. And then in order to get this 7, I should put a 0 here. And hence I will get 7. Okay, here we go. So this is the thing. And similarly, I can definitely, just change the thing as we did before. Let's say, suppose I have matrix, let's say 0, 0 to save my life, 0, 0 equal to, let's say 10, and then I print matrix. So matrix 0, 0 is what is this number, right? So I should have everything unchanged except for this number from 1 to 10. Here we go. 1, 2, this is 10 to 3, So that's everything. And you can see, I mean, basically it's the same thing. For those of you who are not who feel not comfortable in writing matrix like this way, here explanations are wrote another way. You can write it like this way. Personally, for small dimensional matrix, I would prefer just like this way, because this one, I don't know, I feel it's even more uncomfortable than the previous thing. So, but basically they're the same. Python can recognize it. The IDE, I should say, can recognize it. No worry. Okay, so here is the like a double level of the list, or some what we can call matrix. Be careful, it doesn't have to be numerical. I can write it in this way. You know, make everything like this. Even here, like wait, let me delete this one. Oh, the keyboard. I really hate it. Nowadays, the keyboard, you need to press the function, then you can use F10. Otherwise, it will be the function, you know, dial computer anyway. So you can see in the list, I can even put a string and a number. It doesn't matter. It's just a list, you know what I mean? So this is actually very, very, very powerful. Okay, so here's the list. And the next thing is the length of the list. So you can actually see if you compare list versus strings, they're pretty similar. Remember, for string we also have the length. So let me have this one, and also I have another thing, which is name equal to name, not main, name equal to whatever name I have. Mary, John, let's use Harry Potter again. All right, okay, so I can have let's say print length of name. And clearly 1, 2, 3. Be careful of length, not index. Length means the total length, so it should be 3. 3. Or of course, if I want to have one more name, let's say put my name here, even. Oops, I can even not put my name. Then it's gonna be 4. Very simple. Okay. Now remember, we still have this matrix. What if I want to know the length of a matrix? Should I just put a length matrix? Okay, to make it, let me write it in this way. Okay, because in this case, the dimension is going to be different. Otherwise, both are 3. Okay, you know what? If you write length of matrix again, it will calculate from the most out layer. In other words, this will tell you the the length equal to 2. Wait, what happened? Oh, matrix. Length equal to 2. Why? Because from the point of view of the out layer, which is this one, so we can see this is length 1, length 2, so length 2. So, but what if I want to see, so this we can consider it like 2 rows, right? But what if I want to see the number of columns? Simple. Put it like this way. This means the length of the zeros. So here, clearly the column 3. Be careful, this is very important, because in many cases we can simply use this one for 2D or even multiple dimensional matrix. We can use this trick to get the dimensions. There we go. And here you can see indeed 3. 1, 2, 1, 2, 3. So in this case, we can know the length. And similarly, we have the index here. And remember, everything exactly the same from the strings. So similar here, suppose I have a data equals to 3, 6, 9, 5, 10 by 10, 6. So first of all, I can print data dot index 6. Again, remember what's the meaning of this one? Which is return the index of the first element, which is 6 in this list. Okay. It should be 1, right? 0, 1. Index is the first one, not in all of them, but the first. And another thing is we can have this syntax, which is value start. So for example, here 6. Instead, I write a, let's say 3 here. What's the meaning? Oh, yeah, here we go. It's actually the Python kind of like auto that's gonna help. So this tells me that I will look for value 6, but start from index 3. 0, 1, 2, 3. In other words, I will start searching the 6 here. And then you can see from here, which is the first one to get 6, which is here, right? And what is the index of this 6? 0, 1, 2, 3, 4, 5. So the result should be 5. Here we go, 5. So it is very important in some cases. Let's say you are looking for or try to find something, and for example, you want to remove those kind of repeated things, or sometimes let's say you just want to do some further data analytics, so you can use this index method to do this. However, be careful of one thing, that if the element is not included, then it will show you error. Suppose here I don't have 7, right? Suppose 8, let's say. Here I don't have 8. Suppose I want to ask you to find 8. Instead of like return to -1, which is find method for strings, remember, it will show error here. 8 is not in the list, it just shows error. So how can we check whether a given element is in the list? So one method is we can use count. Later, I believe in the next slide, maybe. Yeah, in the next slide, I will show it. Another one is something called in. So we can simply say, let's say 8 in data. So data. So this will return a Boolean expression, true or false. So 8 in data is 8 in data. 8 is not in data, hence the result will be false. False. And what if I write, let's say 9 in data? Result will be true, because 9 is indeed in data. 9 is true. So then you can say if true. Oh, sorry, you haven't learned if, but later you will learn what is if. You can use the if to see whether true or not, and then do whatever you like. So this thing. And let's go to number 2, which is the count method. Count shows you how many times the given value shows up in the list. So I can simply say print data.count, let's say 6. How many times 6 shows in this list? 2. So count shows twice. 6 shows twice in this list. How about 10? 10 shows 1. The result should be 1. How about let's say let me make 100. 100 doesn't exist, so it should be 0. 0. See it. So using count method, we can very simply, make it. And that's extremely simple to write the count method. I mean, later you write the if and you write you learn if and the loop, and just a for loop and everything done. Okay. And then after, so we're gonna learn the append and insert. By the name append means we will add the corresponding value in the very end of the list. So let's say here I have the data. I'm just lazy to make it so we can. Oh, okay. Let me just make it shorter. Okay, so this one I can have data dot append. Let's say, sorry. Let's say 3. So this means I'm gonna add 3 to the end of this list. And then if I print the data, you're gonna see it will have a 3 in the end. Okay, here we go. That case 3, 6, 9, 3. So this is append. And insert is a more general function, which is, well, I will ask you to write an index. Insert. I will ask you to write an index. So what does it mean? The index here, 1. So let's have a look at 0, 1, right? That means start from this index. We will push all the elements after it rightward. In other words, I will insert a 3 here. You know what I mean? Again, starting from this index, which is here, push everything rightward, and then insert a 3 right here. So if you see it, it will run. You can see the 3 here. What if I want to insert the 3 here? Simple. You will put 2, because 0, 1, 2. You put a 2 here. Then the 3 will be inserted here. Okay. Question. What if I put 3? What's gonna happen? 0, 1, 2. In other words, you will put a 3 in the very end. And of course, nobody gonna really do things like this. You can simply use append, just very simple, So this is the thing. By the way, be careful of this. Let's suppose data.append. Let's say append 2. What's gonna happen? What's gonna happen is that it will in algebraic exchange. So what's gonna happen is that this is the first element. I will insert a 3 here. After that, I insert a 2 in the end. So it will be -3, 3, 6, 9, 2. So here we go. Okay, so these are 2 things. So corresponding to append and insert, which is to add elements. We have the remove and pop. These are to remove the elements. So remove remove method is to remove the first. Be very, very careful. The first element with specific value. So here, suppose I have this one. Again, let me put, let's say, another 6. It is all remove, let's say 6. So it will remove the first element. So this 6 will still be there. This will remove. Or for a more generalized case, I can actually remove the elements with the given index. So for example, I can write data dot pop 0. What that mean? Sorry. Data dot pop 0. What that mean? This means that I will remove the 0th element, print data, and you will see this -3 will be removed, the remaining 6, 9, 6. Okay, so now what if I write it this way? Pop -2. -2 means the second to last. -1, -2. That means it will remove this number. Here we go. So this number is removed. See it? So this is remove and pop, and also append and insert. Any questions? I believe all those are very, very simple actually. Okay. Again, I want to mention again, I know many of you are experts in Python, but for those who do not have Python experience or coding experience, I would highly, highly, highly recommend you for all those examples, install the IDE and also write it by your hand. Do not think it's so simple, copy and paste. No, write it by your hand. It's very, very important. You may be surprised it takes you, I don't know, maybe 1 or 2 hours. You can learn all of this because I mean, Python is really, really simple compared with other language like C or those kind of C++, especially if you have some age, Fortran, like 1960s, people use Fortran, and that's a disaster. Anyway, okay, so and then clear and copy message method are easier. So first of all, let's say clear. Clear is the easiest, the one I like the most because just clear done. Clear means delete everything. So okay, you see it's empty. That's it. You delete everything. That's clear. And another thing is copy. Remember in the previous thing. Oh, anyway, I removed it. Remember this example, the name thing. So what I was talking about was here. Here, remember this one. So we had this, and I said name2 is a mapping of the name, remember? And hence you do whatever thing, change to the name2 would follow. But what if I really, really need a copy that I do the things to name, but I don't want to change this one? So we can use copy. So let me do it this way. Name equal to, again, use the 3 names. Mary. Oops, sorry. Oh, just dislike this keyboard. Anyway, I got a brand new keyboard, just delivered. John, and then the last name is myself. Okay, name2 equal to name. Again, this is a mapping of name, of list name. Okay, now we have name copy equal to name dot copy. So here we go. This is a copy method. Copy itself. Okay, now again we make a change. Name 0 equal to Peter. Okay, now I will print name. Name2 page name copy. Okay, here we go. See, both name and name2, I have Peter. So the 0th element has been changed from Mary to Peter, but in name copy, nothing changed. So this is a mapping of the name. This is indeed a copy. So you do whatever things to name, it won't affect this name copy. So in case you want to have this thing, you want to use dot copy instead of write name2 equal to name. Okay, be careful of this. This is a very, very common mistake actually. Okay, now let's have a look at an example. So here we have a list for students named these 3 people. Let me just I'm lazy. Let me just write it in this case. And then let me see here. Let me create a new thing, which is under it. Let me create a new Python file. Exercise 2/3. Okay, please excuse me. I'm pretty lazy, so I'm gonna just copy something here, I guess. And then what's gonna happen? And another one, which is grade. Let me call grades for the list, which is 90, 80, and 95. Okay, so find a replace student Ewan and his grade. Replace Ewan and also the grade by Jennifer. And 100. So the name Ewan will be replaced to Jennifer, and the grade, how much I got? Oh, I got on 80. 80 will be replaced by 100. Okay, but do not manually get my grade. Of course, here is an example. I suppose there are some 3 people. In the real cases, you could have, let's say, 3,000. You know what I mean? You basically don't want to search it by by your eyes to find it. So how to do it? We can actually use what? Oh, here I don't know why here I used the pop. But assuming that the names there's no 2 events. Let me make it consistent. Let me make it to very consistent to my example. Easy for you to review. So the second ones, yeah. And then we can actually use what? We can actually use index, right? What can we do is let's say idx equal to what? Equal to name dot index. Okay, so what's the point of this? The point is that it will tell me, hey, where this guy is. I will get the index. Okay, the index 1. Once I know the index, I can do all the things right. Name index equal to replaced by Jennifer. And then also grade index equal to how many? 100. Here we go. No, here not print index. Print name. I should make it to be names, make my life easier, names. And also grades. Here we go. O name, my fault. And you can see indeed my name is replaced by Jennifer and the score is changed from 80 to 100. Yeah, I believe this method is way easier than this one. I don't know why. Maybe I just want to show the function, you use pop, makes the index and then use insert, maybe because of this. But basically, this way is a way easier method, I believe. Okay. Any questions from here? Because after that, I will introduce 2 in my personal view the most important thing for any coding language, which is if statement and the loops. No? Okay. So if statement, again, here, I assume you do not have, coding background. So I start from the very beginning. If statement by the name, which is if, which is a logical test. So for example, if a score is greater than or equal to 60, you say I pass. Otherwise, say you fail. This is just a logical test. And of course, for coding, we have this one as well. The syntax is like this way. If logical interpretation 1, colon, actions 1. Actions 1 means you do, if this one is satisfied, then you do whatever you want. Else if logic statement 2, actions 2. You can have n such else ifs and the final else. This else means if none of these n logical statement are true, then you're gonna do the last one, actions n plus 1. And this else is actually optional. You do not have to always include else. But you will see for if statement, else in many cases are extremely important. It's different from loop or for while or for loops. Else is not that commonly used. For if function, if statement, else is very commonly used. Another thing is the Python feature, which is it uses the indents. These indents are required. It's not like some other languages, like if you say if blah blah blah, and then you have this, right? In Python, no. It's not like C or Java or something. I mean, it doesn't have the bracket. For those things that uses indents. So I believe I wrote here the indents before actions are required. So actually, if you write, kind of you use IDE, let's say a equal to 1, and then it will, give you the indent automatically, so you don't have to manually like print those kind of blanks. So this is the one good thing of the IDE. And also don't forget the column. So these are things. Let's see some examples. So again, let's use the grade. Let's say grade equal to, let me use the flow, write a flow here, and then input your grade. And then I can write, if grade is bigger than 60, you pass, otherwise you fail, right? If, let's say, grade, here I don't need a float anymore, because I put a float here. If grade is greater than or equal to 60, then what would you print? You pass. Else, print, you fail. Then let's run and see. Okay, input your grade, let's say 99, you pass. Input a grade, let's say 59. I hope you will never get a 59. You fail. So this is the if statement. And by the way, I forgot one thing is that, so here I have I have n plus 1 actions, and exactly one, okay, of these n plus 1 sections will be done on exactly one. It's not, it's not at least one or none. No, it's exactly one. So here, similar. We can definitely extend this example to make it more complicated. Have the system which is A, B, C, D, E. So I can write it this way. Let's say if let's say grade greater than or equal to 90, print, you get an 8. Okay, again, quotations, be careful, because here I use single quotation. So here you're going to use the not single quotation. Or here we need an else if your grade is less than or equal to 90, but greater than or equal to 80. I realized one thing, sorry. Okay, I know why I'm writing this way. So first of all, to be honest, this is not a very formal way. The reason because I'm a lazy man. I kind of like want to save the time. But formally, you should use this one. And greater is less than 100 instead of, write this one. Again, this is not a formal way. I mean, sorry about it. I showed a very bad example. Technically, you should use the and, right, this way. The reason I wrote in this and I put a float here is in case your input is not a number. Let's say input I put ABC, you know what I mean? So that it will, okay, let me follow this one. Let me just let me write it in this way, and you will immediately see what's gonna happen. Okay, so let me use if, again, sorry for this very informal writing method, equal to float grade, let's say equal to 100. The else if is greater than or equal to 80. The reason because just in case, I write something non-numerical, so that's the float will fail. Less than 90. You get a B. Okay, then let me just copy and paste. C, D, fail. Okay, 90, 80. So here should be 70 and 80. You got a C. You get oh, here's D. You fail. else invalid input. Okay, here we go. So first of all, let's say suppose I got 87, I should get B. Or let's say suppose I got, let's say 57. Sorry, fail the class. Sorry, I have this one. And then why write in this way? So what if I put AB like this way? Oh no, because of float. Okay, so in this case, we need to use the with syntax. I will introduce later to prevent such kind of errors. But anyway, yeah, if that case, actually, by the way, if I know that the input must be numericals here, you actually don't need to write these things. Why? Because don't you write this? Why? Because by writing else if, you already know that this one is not satisfied. This one not satisfied means it must be either greater than 100. I assume that my input is valid, which is always less than 100. Then it's guaranteed it's less than 90. Otherwise, this action should have already been executed. So that's the reason. Okay, and then here is an example of using the f function if with else if and finally else. Any questions here? I believe it's pretty straightforward. Okay, and basically, I believe this example will show you that the if function here is nothing but a Boolean expression. In other words, what it really cares, Python really cares, or in the if statement really cares is whether this was true or false. So you can write it even in this way here. Let's say is grade 60 plus equal to true. So here means I define a Boolean variable called is grade 60 plus. And then I just simply write it like this way. Is grade 60 print pass else print you fail. And then of course it will print you pass because this is true. You know what I mean? So basically for if function, it is just for each if statement true or false. If true, do it. If not true, go to the next statement. Next logical statement. And if none of these statements are true, then do else. That's it. That's the reason why exactly one of the n plus actions will be done. So here we go. Any questions? No? Okay. And then the next one is a comparison operator. All other operators are simple, very straightforward, like greater than or equal to, less than or equal to, less than or greater than, strictly less than or strictly greater than. Two things, be careful, which is equal and not equal. I know in many languages, let's say, I believe MATLAB was in this way, right? But for most main coding languages, it use interjection here. So here we go. And also equals, equal. You know, what's the difference between equal and equal? Because this is logical comparison, and equal is just, you know, operator. The not operator, it's kind of like give the number. So let me show you example here. A equal to 1, and then if a equal to 1. By the way, you can put, you know, a blank here or not. I mean, all these are not a big deal, or you can even put things here. No problem at all. But absolutely do not put things here. Why? Because again, Python uses indent to determine the structure. You make this, it will immediately be error. Okay, so if a equal to a, let's print a equal to a. Okay, then of course I will print a equal to a. Here we go, right? Okay, or I can write if a is not equal to, no, not equal to 2, print a not equals to 2. Of course, this is also true. A not equal to 2. Okay. Question. What if I write, remember before I write in this way, right? What if I write in this way? Let me remove those things. You can actually see ID already show you something like this way. This means it's error. Why? Because here you want, remember, this should be a logical statement. Here you write a equal to 1 means give 1 to variable, make a's value to be 1. No, what I'm doing here is to judge, to test whether a equal to 1 or not. It's a logical comparison. And that's why you must use equal instead of 1 equal. It's gonna be wrong. Okay, so this is the difference. By the way, I want to show you another interesting thing. So what if I put all this together if not equal to 2? Oops. Sorry. Print. What's gonna happen? Will it print both of them? No, it won't. You know why? Because again, remember here, exactly one of these actions will be executed. So Python sees this one, it asks you, hey, whether a equal to 1, yes, a equal to 1. So this one done. The whole if structure is done. It won't go to else if at all, because why? Exactly one actions will be done. So this one done. The whole if structure is done. You know what I mean? So it won't come here. Okay. So by the way, when you're writing your code, pay attention to this thing. Okay. So I believe everything's pretty straightforward. And here are the things and or not. So this is in the logical statement here again. So in some cases, it's not easy, like a equal to 1 or something. I need to have more conditions. Let's say b equal to -2. And then now I have if a greater than 0 or b greater than 0. So, wait, sorry. I was looking here. I should do this one here. If a greater than or equal to 0 and b is also greater than or equal to 0, print, let's say, not, well, I wrote a but negative. Anyway, not a big deal. Not non-negative. Let's say both. Not, both non-negative, sorry. Both, I forgot an H here. Both non-negative. And of course, this is false. Else, print at least one negative. Okay, so clearly it will show at least one. Why? Because it's not satisfied. End means end. So if I have an end, that means statements, this statement and this statement, both of them must be satisfied. As long as one of them fails, let's say here b equal to -2. So this one fails. This one is successful, but this one fails, then it's going to come here. So this is the meaning of and. However, if I make it to be or, the logical or means one of them. As long as one of them is satisfied, or both of them satisfied, then the conclusion here will be true. So for example, A is greater than or equal to 0. This is correct. So as long as one is correct, the whole statement here is correct. Then it will say, but of course, I mean, it will do this one. Of course, here I cannot say both non-negative. I mean, the sentence itself is wrong, but it will do this. Okay, so let me change it. FAO, then let's see, at least I should make it at least one non-negative. Else means what? Fail. That means both negative. So it will show you at least one non-negative. So this is logic or. And another one, not. Not is the opposite. So for example, to make my life easier, if not, okay, let me write it. So if a greater than 0, print a greater than 0. Of course, this is correct because indeed a is greater than 0. Okay, but what if I put not? Not means the opposite. So if this is true, with not, it's a false. If this is false, with not, it is true. And then you will see doing nothing. Why? Because this one, maybe I should use the else. Else. Let me print. Ha ha ha. And it will print. Ha ha ha. That's it. You know what I mean? So this is or. Let's say this. Let's make a fourth one. If a greater less than 0. And indeed, a is less than 0. Indeed, a is not less than 0. Sorry about it. So it should go else, which is haha. So if I run this one again, it should be haha. But if I add a not means what? Again, false becomes true, true becomes false. Then it will do this way. See it? So these are the things and or not. These are things we'll see a lot in this course later because we'll code all those things for the machine learning, the basic things. Okay, and the next one is something in and nothing. I believe I've already mentioned here. I remember I had something which is use the count function and then I cannot see where it is. Okay, here we go. We've already used in here. But here we're gonna have a more formal introduction here, which is in or nothing. So here, suppose I have a list called pets. Let's say cat, dog, and also bird. Okay, now I'm gonna say if cat in pets, be careful, it's case sensitive. Then what's gonna happen is, why just an error? I don't know why. Ah, that's why. Pets, not pet. Here we go. If cat in pets, then print cat is included. And then I can write another if let's say fish not in pets included. Okay, so today we'll see. Cats included, fish not included. Be very careful. If I change the C to C here, it will be not, it will fail. You see it? This one does not show anything because it's case sensitive. You must have this. Yeah. So this is in or nothing, which simply means whether the element is in the list or not. So it's pretty simple. And let me see here, print. Okay, and similarly, we don't have to print like this way. We can directly print a logical statement, which is, say, I can directly uh, print. Let's say cat in pets. To be honest, as a good habit, I'd better have this one to be the capital cat instead of the small cat, pets. Okay, so here, let me run it. It will show true because indeed cat is in pets. If I put it as a small cat, lowercase, and then it will show false. False. Okay, so this is a logical statement versus if I write before, like I write in if. Again, if it just tests true or false. So it's a logical text. Any questions here? No? Okay, then let's do an example. Another exercise here. Exercise 2-4. Okay, in this exercise, let me see what's gonna happen. Suppose standard tuition per credit is 10,000. 1,000. Sorry, tuition is 1,000. And then the tuition can be waived if a student's overall GPA is greater than or equal to 3.9. Well, that's a super good policy. I hope some university can really apply it. So it will kind of really encourage all students to become excellent ones, with a high GPA to be 3.9. In addition, if this one is not satisfied, then a student can get 5% tuition reduction if the GPA is higher than 3.5, 10% tuition reduction if the student is a veteran, or 15% reduction if a local student here, because it's a course from Alabama, so I said Alabama resident. So one more thing is that students can satisfy all of them simultaneously. In other words, it doesn't mean all this choose one, because all of them choose one. It will be if else if the structure. But here they can make it simultaneously. In other words, what it will be if. Okay, so let's code it. So first of all, the standard what tuition is 1,000, right? But here I need to ask whether your GPA is greater than or equal to 3.9. So okay. Oh, sorry. Keyboard anyway. So first of all, I need to get GPA equal to, let's say, float. Include your GPA. Okay, so that in this case, I get the GPA and the standard tuition is 3.9. So now I just simply ask if GPA is greater than or equal to 3.9, then tuition is 0. And the final line, I need to print the tuition. graduation per credit is tuition. Okay. Then what else? If this one is not satisfied, then I need to see whether a veteran, and then whether it's sorry, here whether greater than 3.5, which will get a discount. Excuse me, discount of 5%, here discount of 10%, veteran, and then if Alabama resident, it's gonna be 50%, right? 15%, right? Okay, so this means else. If your GPA is not 3.9, because that's 3.9, then 0. I don't need to do anything else. If it's not, then first of all, it's going to ask you whether GPA is 3.5. So here I'm going to see if GPA is greater than or equal to 3.5, then I can have what? Tuition equal to tuition. Let me write another one first. Tuition equals to tuition times how many? 5%, 0.95, right? However, we're using Python here, so you can simply write it this way instead of writing this way. So you just use, time equal to 0.95, and then done. Sorry, again, I forgot. I don't need this column at all. And then what else? Shall I use else if? Let's say, for example, else if, let's say, whether you're a resident or something? No, be very, very careful. All these three structures, three things can be satisfied simultaneously. In other words, you should have if, instead of if, else if, okay? So, and then I need to do one thing, which is, oh, sorry about it. I need to ask the three questions, whether you are a veteran, whether you're a AL resident. So is that veteran equal to input? Are you a veteran? Make a yes, no. And then is AL resident equals input. Are you an Alabama resident? Also yes or no. Okay, so here we go. We can use if is veteran. I use the upper just in case people, sometimes may put the lowercase of the y, so that it will be upper y. Y. And percentage is 10%. Y. Then what's gonna happen? I will have the tuition, how many? 15%. Okay. So now finally it will calculate my tuition. Okay, that's right. It. Oh. Now what's happened? Input your G. Oh, great. Okay, input your GPA. Say suppose I'm 3.95. Okay, I realize, you know what, let me think about this. Actually, here we go. We can actually put those two things here. Why? Because if my GPA is already greater than 3.9, it's done. I mean, who cares whether you're a veteran or a resident, it doesn't matter. Okay, so let me stop it run. Okay, that's 3.95. It should directly print. Your duration per credit is 0. Okay, now suppose I'm not that good. Suppose I'm a 3.6. Then it's going to ask you, are you a veteran? As we use the upper, we can even use the kind of small y. And also, are you an AL resident? I should have a space here. Let's say yes. Then duration in this one. How can we calculate it? Because of what? Because I can have 1,000 times I am greater than 3.5. I get 95% discount. I am a veteran. I get a 10% discount. I am a Alabama resident. I have 85%. And hence, you see, I get this number. Or I can do something else. Let's say okay, here. Let me run it again. Suppose my GPA is 3.1. And suppose I am a veteran. Suppose I'm not Alabama. So how much I should get? This one I'm not satisfied. This one I'm satisfied. This one I'm not satisfied. So I should get 900. Yeah. Okay. So this is this example. Any questions? No. Okay. Then loop. Loop is another extremely important thing in actually not in Python, in any coding language. So what is a loop? Loop use a simple language is to save you time. And lazy people like me would run away like loop. So here example, for example, suppose you have a list with elements, with length 1000. So you have, a list including 1000 elements, and suppose they're all numbers, okay? And I wanna have every number plus one. Let's say suppose element 0. So you need to write it like this way: element 0 plus equal to 1, element 1 plus equal to 1, 2 until 999. And then you need to write it 999 times. Who has the time to do this? So in loop, I can just write a several lines, actually 3 lines, and everything's gonna be done. So this is let Python automatically do something with a given condition. It's again a logic test. There are two very common loops. The first one is called while loop, and the second one is called for loops. And in many cases, you will have if statement in the loops. So let's see example. Sorry, here we're gonna see the syntax first. First is the while loop. So while loop is the syntax as a while, logical statement, action 1, else, action 2. So again, this else is optional. By the way, in if statement, else is very common, but in loop, no matter while loop or for loop, else is not that common. So I would say in most cases, you do not need an else here. So this means if the logic statement, only one logic statement is true, is satisfied, then you will do these actions 1. If it's not satisfied, then I'm gonna do actions 2. Or if I do not have this else, then if this one is not satisfied, then I just skip it, do nothing. So again, something important, indents are required. Why? Because Python uses indents to determine the structures. It's not like, like C or something, I like this one and then I have this, blah, blah. No, it's not. It wants to do, by the way, did you see? ID thinks this while's under if, that's why. So it will do like this way. You see what I mean? Use these indents to determine the structure. So it's extremely important. It's you must have it. A second thing is don't forget the column. And third thing is, kind of like the basic interpretation. I think it's better for us to directly see the examples here. Okay, so I have A equal to 3, B, by the way, so it's another lazy man's choice. So if you just have something very simple that you don't want to write it in multiple lines, you just use the semicolon, you know what I mean? This is basically the same as many other languages, but the difference that here you also need, for other languages here, you also need a semicolon, but Python it doesn't matter. And while A greater than 0, A equal to A minus 1, and then I gotta write this B equals to B plus 1. Okay, and then I'm gonna say print AB. Guess what's gonna happen? So first of all, A is 3, B is 0, right? Okay. So it asks you, hey, is A greater than 0? Yes. Now A is 3. So of course A is greater than equal to 0. Okay. If this is true, then I'm gonna do the following, which is A equal to A minus 1 and B equal to B plus 1, and then print. So now our A's are what? Are 2 and our B's are 1, right? So it will first print 2 and 1. Okay, now maybe I should write in this one. Let me just A equal to A and B equal to B. That's one. Okay. So I will have A equal to 2, B equal to 1 first. Okay. Now what's gonna happen? hey, is a greater than 0? Yes, 2 is greater than or equal to 0. Hence, a equal to a minus 1, which is 1. B equal to what? B equal to b plus 1, which is 2. So again, we'll have a equal to 1, b equal to 2. Okay, again, ask you, while a is greater than 0, is a greater than 0? Yes, 1 is greater than 0. So a equal to 0 and b equal to 3. And then print a equal to 0, b equal to 3. Now, is a greater than 0? No, because a equal to 0, then do nothing. Of course, if you have an else, oops, sorry. If you have an else here, it will do the else. But let's have a look at this one first. So exactly as what we just mentioned. A equal to 2, b equal to 1. Second time, a equal to 1, b equal to 2. Third time, a equal to 0, b equal to 3. Why don't continue? Because now your a already equal to 0. So a is not greater than, strictly greater than 0. And hence I stop. That's it. Okay. Now what if I have an else? You can do, let's say again, print, haha, for the, here I print, but it doesn't matter. It's just an example, you know. Then finally you'll see, haha, why? Because finally a equal to 0 and b equal to 3, and then ask you, is a equal to 0? Sorry, is a greater than 0? No. So it's gonna do the else, which is haha. So haha, that's it. Okay, I believe this is a very simple example. Any questions? No. Okay. Now let's see a dangerous code. Guess what's gonna happen? So every time a equal to a plus 1, then I print a. And you can see that this is forever satisfied because from 3 plus 1 plus 1 forever, it's going to be greater than or equal to 0, right? Okay. So you run it at the console here will forever run the number. And hence, you have to stop it. You can use Control F2 or just press it because my keyboard, I will have to put the function. I mean, I need to put 3 keys. So I really don't like my keyboard. So I use the mouse. But if your keyboard is better, say you don't use HP or Dell, this kind of keyboard, you know, you can directly put, you know, control or something. You don't have to put a function. So that's the same. By the way, in almost all cases, when we are coding, definitely avoid these cases, which is a dead loop. In very, very extremely rare cases, we may want a data loop, but it's really extra, like you try to hack someone, I mean, something like that. But it's really rare, I mean, extremely rare. In almost all other cases, definitely check your code. Do not use those kind of loops. Lucky here, don't use a pointer. In some cases, let's say you're running C, use a pointer for some internal system, I mean, memory address, and you have a data loop. It's not joking. It can kill your computer. But anyway, okay. So here's the example of the data loop, and also we will have the one minute. We'll have the break and then continue. So break means break. That means I will end the whole loop. It doesn't matter after it, you know, like my statement is true or not. As long as I see break, the whole loop, the whole while loop is done. Let's again use this example. Let's say a equal to 1. And then while what did I write here? While a is less than or equal to 10, print a. Well, actually, I have it here. Print a if a equal to 3, break. And then here I make a plus equal to 1. Be careful. The a plus equal to 1 is this level. It's not in if, okay? And that's the reason why you need to have the dent. So in other words, this one, the whole if structure and this one, they're in the same level. This break is inside this if. So that's why Python uses indent to tell the structure. That's why the indents are required. You must have the indents. Okay. So what's gonna happen is here is that what if I don't have this? Let's say I delete it. In this case, what's gonna happen? It's gonna just print, right? A that's equal to 10, yes, so it's gonna print 1, 2, 3, 4, 5 until 9. 9, and then 9 plus 1 equal to 10. It will print from 1 to 10. Let me do it. Yeah, you can see 1, 2, 3, 4, 5 till 10. Okay. Now I have this one. What's gonna happen? Okay, so again, let's see, a less than or equal to 10. Okay, so a originally equal to 1. Yes, it's less than or equal to 10. Then now if a equal to 3, break. So it's not equal to 3. So it's going to print 1 first, and then a plus plus, then sorry, a plus equal to 1. So that that's going to be a equal to 2, print a, which is print at 2. Is a equal to 3? No. Okay, continue. A equal to, a plus plus, sorry, a plus equal to 1, and then it's going to be 3, then print a as a 3. But the problem is that now a does equal to 3. Break. Break again means quit the whole while loop, the whole loop. Say, I'm done. It doesn't matter. You say, hey, a plus 1, 3 plus 1 equal to 4. 4 still satisfies a less than 10, right? No, it's gone. As long as I see a break, it's gone. So it will just print 1, 2, 3. Let's see it. 1, 2, 3. You know what I mean? Because it's just done here. Okay, so this is the meaning of a break and the whole loop. By comparison, we actually have something not the what continue not break the whole loop, but break the current. I should say stop the current iteration. So what if I change this one to continue? So continue is the thing, which is I quit the current iteration, and then no, I better not use example because it will be a dead thing again. You may want to see why, but sorry about it. This means comment. I will introduce this later in this lecture, but let's rewrite it. A equal to 1, while a is less or equal to 4, and a plus equal to 1, and then if a equal to 3, and then continue. Print a. Okay, so let's see what's going to happen. Again, a equal to 1, and then a is less than or equal to 4. A plus while a is greater less than or equal to 4, and then a plus equal to 1, and if a equal to 3, continue. Otherwise, print a. Okay, now a is not equal to 3. So first of all, a equal to 1. 1 plus 1 is 2. So I will print a 2 here. Okay, now 2 still less than or equal to 4. So I'll continue. 2 plus 1 equal to 3. Here is 3. Continue. Continue means what? I'm gonna directly go to the statement. I'm not gonna do this one anymore. This is the meaning that I will stop the current iteration. You know what I mean? So that I'm not gonna do this one. Once I see continue, I will directly go to the logical statement, which is whether 3 is less than or equal to 4. Yes, 3 is less than or equal to 4. So 3 plus 1 equal to 4. 4 is not equal to 3, and then I will print a 4. In other words, I will just print 2, 4, and then finally have 4 here. 4 still equal less than or equal to 4. 4 plus 1 is 5. Not equal to 3, print a 5. 5 is greater than 4, so it doesn't satisfy this one, so I'm done. In other words, it will print 2, 4, 5, but skip 3. Why? Because of here. Get the point? Continue to stop the current iteration of the loop, but it won't stop the whole loop, while the break will stop the whole loop. Once I see a break, the whole loop is done. But if I just if I just see a continue, not the whole loop is done, but just the current iteration is done. So this is the key difference. Okay, now let me delete this one. Let's see, what if I run this one? What's gonna happen? Okay, so a less than 10, print a. Yes, I print a 1 here. If a equal to 3, continue. Okay, not equal to 3, a plus 1. So a equal to 2 now, not equal to 3, plus 1. So now a equal to 3. Okay, if a equal to 3, continue. Continue means what? I'm gonna go here. A is 3. 3 is less than or equal to 10. Print. Again, a equal to 3. Is that correct? Yes, my current a is 3. Continue. 3, continue. You know what I mean? It's going to be a data loop again. So in other words, it will print 1, 2, and then 3, 3, forever 3. Let's run it. I mean, 1, 2 is too fast, so you cannot see. Then it's a data loop. I have to break it. Oops, shit. I need to put the function key again. Okay, here we go. So I mean, what I did was let me run it. Let me run it again. Okay. Let me run this one again. So you will see here. So this means stop me, and you can see the shortcut is Control plus F2. So, but in my computer and in my keyboard, I need to put Control function and F2. I always forget function, and hence And if you go to the very top, you will see it's because it's too many, so Python doesn't show it. But technically, it should print 1 and 2 first, and then forever 3. Okay, be very careful. Again, do not write those kind of dead loops. Okay, and now read the following code and tell the results. What's gonna happen? So first of all, a equal to 1, while a is less than or equal to 4, print a. So I will print 1 first, a equal, I believe this is exactly the one I will just copy. So it's gonna be 1, 2, and forever 3. That loop, be careful. The second thing, a equal to 1 while a is less than or equal to 4. Okay, so actually no difference, but I put this print here, right? So a plus equal to 1, so it's gonna be a equal to 2, and then it's gonna be a 2 here, and then a equal to well, I mean 2 here, and then it's not equal to 3, and then I will print a 3 here. 3 is still less than or equal to 4. A equal to 3, continue. A equal to 3, continue. Equal to 3, continue. In other words, it will be 2 and forever 3. You know what I mean? Both of them are dead loops. Be very careful. If you don't believe, I can just simply run it here. Wait, 1 minute. Sorry, my fault. A equal to 3, continue. Give me a second. Why is my fault here? Give me 1 second. Okay. Did you see something interesting? It's not finished because once it's finished, I will say something is finished. And the see here, it's still a dead loop, but it's kind of like an invisible dead loop because it does nothing. You can see here that, so I'm currently still running this code. You can see here, but it's just a dead loop. But you say, wait, dead loop, why don't it like print 3 something like this way? Because it's here. If a equal to 3, continue. I didn't print it, you know what I mean? Okay, continue here. A equal to 3, 3 is less than or equal to 4. Okay, continue here. A equal to 3, continue. A equal to 3, continue. In other words, it's just a loop around here, you know what I mean? It doesn't go print at all. And hence, it's just like this way. You can see the code is still running, and here I have to manually stop it. Otherwise, that's wrong. It's also a dead loop. Okay, be very careful. Definitely try, especially if you're new to coding. Always think about it, try to avoid this kind of dead loops. Okay, and finally, let's make an example while loop exercise. So code a guess number game. Suppose we have a secret number, integer between 0 and 9. Ask a user to guess. Print guess a number between 0 and 9, and in 3 times, if the user gets the correct answer, then you print you nail it. Otherwise, if the user just fail in the all of these 3 times, print game over. So let's see how can we make it. What's the name of the exercise? 2.6. Okay. So let's make a new exercise 2x. Okay, so first of all, what do we need to do? We need to guess the number, right? Let's have a true number equal to what number you want to like. Say today is April 11th. Let's say April. Let's say 4. And then I want to have let me see here. 3 times. Okay. The maximum guess equal to 3. And then I will use a 1. 1 means what? 1 means how many times I've already counted, assuming I'm wrong. So now I will have a while I is less than or equal to maximum guess. So if it's less than or equal to the maximum guess, I can still guess, right? So I will say guess equals to, let's say, int input. Int is, because I know the number of the gas must be an integer instead of a float, so I can do it. Let's say gas an integer between 0 and 9. Actually, you know what? I can actually make another thing. Let me make this. As I call it chance left. It means how many chances I still have. Chance left equal to maximum gas. So here I can have, let's say, chance left number of chances left. Okay, so here. I will put integer here. And then what shall we do? So by the way, technically, I mean, if you really make the code robust, you need to have a judge here, which is whether the input is really a number from 0 or 9. But here, since it's just an example, to make my life easy, I always assume the input is an integer between 0 and 9. Okay, so now let's say if the gas equal to our true number. What equal to our true number, then I'm gonna print you nail it, right? But what if it's not? If I don't, it's not a true number. So else I will have what I plus equal to 1. That means the number, I guess, is already increased. And meanwhile, don't forget that the chance left minus 1. So okay, by the way, one thing I can actually make it. No, actually, I must need a break here because if I nail it, it's done. I mean, I win the game. It's done. I don't have to make the while again and again to let people guess again and again. You know what I mean? So I just use a break. Here is the break means because I finished the whole game. So I don't need to run this while loop anymore. That's the thing. Okay. And then the thing is here, while I is less than or equal to maximum gas. So what if let's say 3 times because of my maximum gas is 3 times? All the 3 times I fail. What's gonna happen? So this is I need to consider when I is greater than maximum gas, which means all the 3 times a plus 1 I fail. Then I will have an else. Be careful. This else indent is under this while level. Else I'm gonna say you lost. You lost the game. Or game over, whatever you want to call it. Okay, let's do it. So of course here I of course know because I'm cheating here the true number is 4, but assuming I don't know, let's say 1, guess integer, still wrong. And you can see 2 chances left. I guess a 2 here, still wrong. 1 chance left. For example, I guess a 3. Okay, you lost the game. That's it. Or I can do it again. Let's say the first time I guess it's 8. Wrong. And the second time, let's say suppose I make it. Let's say I guess a 4. You nail it. See it? And so this example shows you how to use a while and else. And of course, I mean, in the real things, you can use our library and make a function that you let user A to input a secret number and let other people to guess it, so other people don't know it. Here, just an initial stage, I give a very simple example here. Clear? So this is a while loop example. And after it, we will have a for loop. Let me make this one here. After a while loop, I will have a for loop. So for loop basically is also a loop, but the difference is that it's usually iterating over a sequence, for example, a list. So I will always say for example, x in whatever list. So the syntax is for element in sequence, actions 1, else actions 2. The logic is exactly the same as while. And let me see. Here again, indents are required. Don't forget the columns. That's it. Okay, let's see some examples here. Oops, sorry. Let's say for x in a string cat. Be careful here, the string is not a list. Print x. So basically that means, okay, for each element in string x cat printed. By the way, it doesn't matter. You say, so why it's x? It doesn't matter what do you like. So first of all, let's run it. So it will do nothing, just print CAT, because for each element you just print it. You say, hey, I don't like X. I want to say Harry Potter. Harry, can I do it? Yeah, you can say Harry. It doesn't matter what's the name of this. This is just kind of like a name of this. It's just like when we're doing this kind of equations, x equal to 2. You say y, you name the variable to be x. Why don't you name it to be y? Yeah, you can name it to be y. It doesn't matter. Okay, and then similarly, let's say suppose I have a list called pets equal to, let's say, cat, dog, let's say fish, and then I'm gonna say for pet in pets, print path. Again, this paths doesn't matter. It shows the list. But this path doesn't matter. It's just, again, a variable. You can name whatever you want. So let's run it and call you make a cat, dog, fish. Or you say, hey, for X, in paths in the list paths, and then print X. It will be exactly the same thing. Okay. And also I can use the else similarly for passing pass print. Otherwise, else, that means when we're done, then we're gonna print. That's wait 1 minute. I need to use a double quotation. That's all. And then it will print all the cats, all the paths, and then print. That's all. So this is else. Again, else is optional, and in most cases you won't see else, because really else for loops are not that common. Not like if you will see a lot of almost everywhere, but for or while loops, no, it's not so common. Okay, so now more examples. We can use this one to calculate. For example, if I have a price list here, price is equal to whatever the number, 8, 10, 16, and then total cost equal to 0. So I can use for price in prices, total cost plus equal to price. So what do I mean? That means for each number, total cost equal to total cost plus this price. So okay, so first of all is 8, then plus 10 plus 16 is how much? 34. So it will be totally $34. And then print the total cost is total cost. Here we go. So we'll show the total cost is $34. So that's the thing. And also I can use break or continue, and the meaning is exactly the same as the break and continue in while loop, which is break is what is to quit the whole loop, the whole for loop, while continue to just stop the current iteration and go to the next iteration. Let me you run this example as well. Numbers, let me for this, usually you better have a capital, have a letter, a title structure, which is the first one is uppercase. 3, 2, -1, 5, 4, number in number. Sorry about it. Here it doesn't matter. Number in numbers. Here I found an if number is less than or equal to 0, break, and then print. Be careful. Sorry. Be careful. The indent here. Print numbers. So this means what? I only print positive numbers, and once I see a negative number, I quit. In other words, here I will only print 3 and 2. Even if this 5 is positive, I want to print. Why? Because it's break. 3, 5. Okay, so what if I change this break to be continue? So this 5 will be printed. Why? Because once I see -1, I continue. In other words, I'm gonna go to the next iteration, but we are still in the for loop. So and then I will see a 5. Is 5 less than 0? No, 5 is greater than 0. So print 5. So you will see 3 to 5. There we go, 3 to 5. Okay. So this is the for loop, and we can have the nested loops as well, like what we saw before, like I call it a matrix or nested list, right? Similarly here. So I can say, for example, for X in range 2. By the way, range 2, the meaning is a sequence, which is from 0 to 1. So range n means a sequence from 0 to n-1. For X in 0, range 2, and for Y in range 3. I already use 3 here, great. And then I'm gonna print let's say X, Y. Okay. So what does it mean? That means for X equal to in range 2, so in the beginning X is equal to 0, and then for Y is in range 3. So the first one, Y will also be 0. I better run it first. Yeah. So X will be 0, Y will also be 0. But next time I will go this loop, the inner loop first, because until I finish the inner loop, I will go to the outer level loop. So in the inner loop, so my Y, the next Y will be 1, so it will be 0, 1. The next Y will be 2, 0, 2. And then again, range 3 means from 0 to 2. So this loop is finished. Now I go to this loop. in which x now equal to 1. So I will say 1, and again, y is 0, 1, 2. So 1, 0, 1, 1, 1, 2. And the range to, ends in x equal to 1. So here we go. Okay, so this is a nested loops. It's actually pretty simple. In most cases, we run those kind of things like in the matrix. I want to say for I in column and j in, for I in row, j in column, something like this. Next one is something like a similar example. Let's say matrix equal to, let's say 1, 2, 3, 4, 5, 6. And then I will have the row number equal to length of matrix. Again, remember what that means? I will calculate the outer one so that I will have 1, 2, 3. I will have 3 rows, right? And then how to get a column number? Column number equal to length of matrix, what? 0. It doesn't have to be 0. You can make a 1 or 2 as well, because the maximum index of the outer matrix 2. So I mean, I just use 0 because the 0 element always exists. And then I have 4 as a element. Let me use m in range row number. What I try to do is that I try to have every element plus 5. Of course, if you later use NumPy in array something, you can just make it a +5. But here, suppose I don't know what is NumPy. I just want to do it in the list. So I can use a for loop here. And hence I have, first of all, I consider rows and then consider column and range column number. So this means from 0 to, let's say, suppose here, what is the row number, by the way? Row number should be equal to what? Should be equal to 3, right? Again, this is a comment. So when Python see this one, Python, this is just to let us coder to read. Python will ignore it when it see this count. Then so I can write illustration to help human, to understand without interrupting without interrupting the code. Equal to 2. I have 2 columns. So this means for m in range 3. Range 3 means what? 0, 1, 2. For n in range 2, that means what? 0 and 1, right? So I have matrix m row n column plus equal to 5. That means each element gonna be at 5. Finally, print. Be careful. The dent is here. This is this level, not inside. Because if inside, every time it will print. But finally, we just need to print one time. Print matrix. Okay, here we go. And you can see indeed, each element is added by 5. So this is the thing. Any questions here? No. Or we can do something very, very similar. I just, I don't have to do this way. I can simply just let me say print. Let me see, how can I print the whole element? So here I can say for row in matrix and for x in row. Sorry, in matrix. So what does this mean? So that I will see so for row in matrix, that means row equal to this one, row equal to this one, row equal to this one. And then for x in row, so x is this one, it will be 1, 2, and then 3, 4, and then 5, 6. No. I really dislike this keyboard anyway. Okay, it's function shift F10. Stop and run. Uh-oh. Okay, here we go. So 1, 2, 3, 4, 5, 6. So this is the thing. Okay, then finally let's finish a loop, and also we'll have a mention the comment. So for the loop exercise 2.7, for a given number list, write the code to find the maximum, smallest minimum number in this list. So first of all, let me just create something here. 2.7. So you will have a list, and then you'll have a list, and then what? You will have find the smallest number, right? So first of all, I will need to kind of create a list, and list equal to, let's say, input number list, and then let me see. Okay, sorry about I was cheating a little bit here because I need to know the separate because we will use split. And then let's say separating elements with, let's say, with comma. Okay, but be careful that here all these number these number lists are what are strings here. So later I will need to have the float. So first of all, I want to have a split number. So, okay, so now if I print num list, what's gonna happen? So let's see what's gonna happen. So I run this again, and then I will have, let's say 1, 2, -5, 4, for example. So I will have this one, right? But this is not what I need. Why? Because I want to have the numbers, so I need to have a split, which is, let's say, num list split equals to num list dot split. And this one should be split by what? By comma, and hence if you see here, split, and it will be just a list. Let's say 1, 2, 2, 1, 2, -3, 5. So it will be like this way. However, don't forget one thing, that all of these are what? All of these are still strings, so that you need to have the float, right? And hence you will have let's say, so the idea of this, I will start the middle number equal to the first element. Then I will use a for loop, go to the next element. If the next element is bigger than the first, we're looking for the smallest number, right? Yeah, smallest number. Let me see. Smallest number. Okay, so if the next number is smaller than my current smallest number, then the smallest number equal to the next number. Otherwise, do nothing. Similarly, I make the whole loop, and then finally, when it goes out, must be the smallest number. So this is the same. So what I'm gonna do is here is let's say main equals to, let's say, float num list element number 0. So I will give the 0th element to the minimum. Okay, now I can do it like this way. For number, let's say for x to save my life, in number list split, if, be careful, you need to have the float here, otherwise no, actually you don't have it because you already have this one. No, this is the main, so I cannot, I must have this one here. If the float number, if the float x is less than the main, that means what? Say suppose this number is less than this, so I will let main equal to this number, right? And then continue. Main equals to, let's say, float x. And then think about it. Finally, I do all the things. I will always get to the minimum number, right? Because once something smaller, it will be replaced. And hence I have print main and done. So let me say 1, -1, -1, 2, 5, -3, 5. So it will tell you -3. Because I use float, that's why it shows 3.0. Okay. So this is one example. Another example for a given list, remove the duplicate elements in the list and print the new list. Great. So to make my life easier, I here I directly get it. And later when we learn the function in the next lecture, we will see that I can just simply input a function here. So every time you don't have to rewrite it. But here, just to make my life easier, I will directly give this list let's say list equal to whatever number. Let's say today's 4, 11, 20, 11, 20, 24, 2024, whatever. I need to reduce the duplicate. So let's make another 4, another 11, and then 21, another 4, -1, something, it doesn't matter what is the number. And then how can we remove all the duplicated number? Case number 1 is that you can play the index, but be very careful that once you use pop method to remove something, you need to be very, very careful because the index is gonna be changed. Why? Because the length of the list gonna be gone. So here I introduce another method. That method is easier for coding, but trust me, if your list has billion, trillion of the length, then I'm afraid the first method is more efficient because the method I'm going to introduce now, you're going to make a copy of the current list, which will occupy you a lot of space. But here, let's make my life easier. My life easier, not a computer's life easier. I create a new list called unique. So in the beginning, unique gonna be empty. What I'm gonna do is that, well, I'm gonna add elements from list to unique. And I want to make sure that the element added are not in it. Because if the element, let's say here, a 4 is in it, I'm not gonna add it anymore, right? And hence, as long as I make a for loop of all the elements in list, I can make sure that the unique list must be unique. No element is going to be repeated. Why? Because if, for example, if this 4 is repeated, it will not be. So what I'm going to do is to make a 4x in list, but I'm going to be if is not in. If x is not in list, then I'm going to do something. Unique dot append x. You see what I mean? Now I print unique. And here we go. Wait. Sorry. Wait, how come? Wait, let me. Oh, sorry. Nothing less. Sorry. Yeah, nothing unique. Because if x not in list, then nothing. Because here as 4x in list. If x not in list, no, sorry. Nothing unique. There we go. So I show you 4, 11, 20, 24. See, this 4 is filtered out. 11 is also filtered out. 21 is kept. 4 is filtered out. 1, that's it. I mean, you can do whatever you want. Let's say you have another -1 and another 20, and then for 55, you do it. It's going to be the same thing. As well, just filter out. So everything. As I mentioned, short of this way is that you will create another thing. Suppose if you know the big O notation, this in terms of space, this is gonna double. So if your list is huge, let's say trillion, billion, don't use this method. But I mean, in this fundamental course, it's okay. Don't you worry about this. Okay, so I believe that's everything about this lecture. Oh no, we finally have one more thing, which is comments. Actually, we've already seen comments here. So here we introduce 3 types of comments. Type number 1 is here. We just add something. So comments, the most important thing, important reason, important usage is to let us human to read. So for example, here I say, oh, append the number, let's say the element to unique list if it is not repeated in list. So I mean, this list means this list. Okay, so this I may want to put this one. So Python, when in one line, so Python gonna just do it. But when Python sees this pound, then everything behind the pound will be ignored. So then Python will directly go to the next line. Again, if see a pound or a comment here, skip it. Everything after this pound will be skipped. So this is thing number 1. Thing number 2, sometimes, suppose I have many lines here. Suppose I have 100 lines here. It's not inconvenient. It's very inconvenient for me to add upon each line like this one, right? Is there an easier way? Yes, you can just simply select all the range, all the code that you try to comment it. Then you press Control and the backslash. Let me show it. It's this one, which is the same key as the question mark. So you put this one, it will automatically comment everything, and you press choose it press it again, it's uncommon, common, uncommon, common, uncommon. So this is another method. Method number 3 is that if I really have a lot, let's say I have 10,000 lines. I'm even lazy to select these 10,000 lines. So what I can do is dot, dot, dot. And you can write whatever things here. Everything between the dot, dot, dot. It will be kind of like be a common, not too much. Nothing gonna be executed here. So these are the 3 methods of the comment. One more thing I want to mention is that in addition to the function that I mentioned that it shows some illustrations to let human read. Another reason is, for example, suppose I have something wrong, so I can comment this one. I wanted to remember. Yeah, I believe my mistake here is a very good example. Remember before what I wrote here, I said if X not in list, right? Okay, so suppose I don't have this one. So clearly this is wrong. And then if I run it, it will be empty, right? So I search it, I'll check it and say, oh no, it should not be in list. But suppose this line pretty long, and also I'm not 100% sure that's a mistake here. What I can do is I add a prompt here to comment it, and then I write another thing. If X not in unique, then I'll run it and I see, oh, correct. The result now is correct. So I know this one is wrong. You know what I mean? Just in case, for example, if this one also wrong, so maybe I can recover it or do something else. So this is another trick. Or sometimes you can simply just use a breakpoint if you're familiar with Python. That's another thing you can do. But I mean, for me, I'm pretty lazy. Usually, I just use the comment, and I have more freedom instead of just line by line breakpoint. So this is the thing for a comment, and actually later we'll see a lot. So here are some examples because they're extremely simple. So I'm not gonna operate it here. So for example, print hello world. So I make a comment here. This line the whole line will be skipped. Again, remember everything behind the pound as a comment will be skipped. Also here, print, I like machine learning, whatever, and I do whatever things here. As long as Python C, dot, 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 it will just skip it. Let me do something here. Okay, so here, I mean, which one's wrong? This one's wrong, right? So I will comment this instead of deleting it, and then I can write whatever I like. I love Python, blah, blah, blah. You do whatever, and it won't show error. I want to show that, sorry. However, if you delete this dot, I mean single quotation, 3 single quotation, if you write this way, no, it's wrong. Because Python doesn't understand. Hey, what do you mean here? Invalid syntax, you see it? Because Python doesn't understand. But if you, let's say you write like this way, or if you have many paragraphs, whatever you want, then everything between this will be just, skipped. So here's comment. So this is everything about lecture number 2. I still have several minutes. Let me have a very quick start of lecture number 3. So lecture number 2, the name is, let me move this one. It's tutorial on Python. I believe it's called tutorial 1. Yeah, Python tutorial 1. Lecture 3 is a bit more advanced, still very basic. So in lecture number 3, let me see what I have. I believe I have functions. Yes, the functions. So remember what we did a lot of exercises here. For example, like a list or something, I have to manually input everything in the very beginning of the code, right? But in many cases, no, I just don't want to, kind of like make this one every time to print it. Let me give you a very simple example. Let's say a equal to 3. Let's say let me use x equal to 3. And now I want to print x square. Oops, x square. Okay, so. Oh no, this is exercise 2.6. Sorry about that. I should not touch this one. Let me use a main. Sorry about this. Let me say x equal to 3 and then print x square. Okay, 9. Good. But what if next time I want x equal to 5, x equal to whatever number? Every time I change like this, so it's kind of like, kind of pretty tedious. So I want to have a function, which is it's really like a mathematical function. I believe, yeah, I have an example right here. Let me just let me see here. Suppose I have fxy defined to be x squared plus 2y plus 1. And then I have, of course, f00 equal to 1, f12 equal to 6, these things. But is there a way that I don't have to every time, numerical put the numbers here? Instead, I can really define a function like this. So there I just put 0, 0, it will turns out 1. 1, 2, it turns out to be 6. Instead of, what I mean, every time I change again. So this is called a function. And the function, a very, very good point thing is that we can always reuse them instead of writing it again. It can make our code very brief and efficient. If you're a lazy man like me, trust me, you will really, really love it. Okay, so clear all joins. Let's see an example here. Wait, before it, I need to define the syntax. So syntax is just df function, column again, tasks is something whatever you want to do. Returns this x means that function has a return value. Let's say x squared, so return value is x squared. So and return value is optional. You do not have to have it. But again, be careful about the indents here. They are required. Okay, so let's see an example here. Let's make my life easy. So let me define, let's say function 1, x and y. What do I have here? Okay, so z equal to x squared. Remember the example I showed here, plus 2 times y. Be careful, you must write 2 times y, you cannot write 2y, okay? But it cannot recognize plus 1. And then return z. And actually, you even don't have to write this line. You can, oops, sorry. You can directly write in this way. Both are same, no difference. So, and then now what you can do is here, again, see the structures. I already break out the structure in definition. So now I can print, let's say, for example, func1, let's say 1, 2, func2, let's say func1, let's say 5, 0. And then let's see the result. Okay, great. Funk. Okay. Funk. Okay. Okay, so we can see x equal to 1, y equal to 2, then it's gonna be 1 plus 4 plus 1 equal to 6. Or if I have x equal to 5, y equal to 0, 5 squared plus 0 plus 1, which is 26. So here you go. So these are things. You don't have to only use it for numerical calculations. You can have another one. Let's say define, let's say func 2. Let me see what I do here. Sentence. Oh. So you're kind of like forgot the column. You will kind of like write something there, print hello world, then plus, let me put a print here, sentence. So what that mean? So you can do whatever thing. So here, suppose again, let me use control and the backslash. So it will, you can see the whole thing is commented. So it will be ignored. Be careful about indent again, print. Oh, sorry. I can't directly have the func because the func itself includes the print. Func2, let's say la 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 la. Okay, so then you can see hello world la 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 la. That's it. Wait, here's something is wrong. Let me see what is wrong. Okay, that's why it's wrong. Okay, so then let me run it. Hello world, la la la. You can write whatever you like. Okay, say ha 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 ha. Then it will be, hello world, ha ha ha. So this is it. And you can see that it really makes the life easier, you know what I mean? Otherwise, every time we do change. But here, I just pack everything in a function and I just put a function, input, output, done. It's a very, example. Before I finish my lecture, let me do the final thing, which is this one. So let me see, what is this one? Exercise 2.6. In the secret number and the maximum gas number are set to be input. Thus, we can easily set them up. Okay, so here due to time limit, let me please excuse me. I'm not gonna directly write this, but it's a pretty straightforward. Let me directly see the number to the function here. So here I define a game, which is again our gas number game. Remember the code right here, 2.6. Oh wait, two. Where's my game? let me see. I should have my game somewhere. Lecture number 2. Is that 2.6? I remember. Let's say gas. Okay, here 2.6. Oh my goodness. I covered it. Looks like I forgot to. I covered it, but anyway, no big deal. We can already borrow the codes here. Remember here we define a secret number here, and then also I believe I call it a true number, whatever it's called. Everything else are the same. But here I have to set up the secret number in my main part of the code, and the maximum guess in the main part. But here I can seal everything in the function. You see what I mean? So secret number, whatever you get, you gives it. And then maximum guess number. Okay, so chance left, everything else are the same thing. The only difference is, oh, sorry about accidentally closed it. White opens 2. I don't know. Anyway, so this is with the function. So here, while you can see actually everything here the same, right? The only difference is that here I put 2 arguments here called secret number and maximum guess. Now here, what does it mean? Guess number 3, 2. That means the secret number equal to 3, and then guess number equal to 2. And hence here I have some outputs that I guess a number between 0 and 9, 2 chances. Why 2 chances left? Because totally, I define the maximum number for guess 2. 2 chances left. I guess 2. The true number should be 3, but I don't know. Okay, so 5, wrong. Again, 1 chance left. Define 2. Again, wrong. So print, game over. Or in the second case, example, 2 chances left. The first number guess 5 again. But the second guess, I successfully guessed it to be 3. And our secret number is 3. So successful, you nailed it. You know what I mean? So again, functions makes your code, you can reuse it and make your code brief and efficient. So this is the meaning of the functions. Okay, so since it's already 7, sorry, my time 7, in the CDT it's already 8. So I will end my class here. And then in the next class, I will try to finish this lecture, and then I will start a little bit for the formal machine learning part, which is linear regression. Okay, that's everything for today's class. Thank you very much. You have a good night. Bye-bye.